let's have a look at a few more applications of differentiating logarithmic functions where we could potentially use our knowledge of the log laws to simplify the functions before we get started. Now, you might recall from the work that we did in the preliminary course that when we've got x raised to the power of -2 in our logarithm, we could rewrite that by bringing that -2 to the front. So this becomes -2 times the log of x to a base of e. Now when we differentiate it, it will be a little bit easier because it just means we differentiate this function here, the log of x, and we multiply the result by -2. So that becomes -2 times, and the derivative of the log of x, well, if our function's x, the derivative of that is 1, over our function, which is x. So we end up with a final result, -2 over x. Okay, in this second example here, we've got two functions being added together, a linear function and an exponential function, a logarithmic function. So we could find ourselves now in a situation where we've got a combination of different types of functions that we need to differentiate. So dy by dx, the derivative of this linear function here is just 1, plus the derivative of our logarithm, remember our result from the reference sheet that we've proven earlier, is the derivative of the function, which is 1/7, over the function, which is 1/7 x. Now, let's tidy that up a little bit. We've got 1/7 being divided by 1/7 of x. 1/7 of x is just x divided by 7. And let's think about it. When we divide and we've got fractions, we multiply by the reciprocal. 1/7 times 7 on x. 7's cancel, and we've got 1 plus 1 on x. Okay, and our last question here is not set up as an equation that links x and y. So let's write it as in using function notation. So then we can show clearly once we've differentiated. And when we're differentiating when it's in the form of function notation, we'll use f dash x to denote our derivative. And when we're going to differentiate this time, we're looking, here's our function, and we're still going to use this result where we've got the derivative of this function, and the derivative of e to the x is simply e to the x over this function, which is e to the x minus 2. And that's our final result.